The purpose of data providers is to obtain hierarchical information so that those who need it can do something with it later. Remember that in data providers, the focus is placed on the output language. A hierarchical structure indicates how that output is designed. This is why we speak of a process of transforming the input data into this structured output. This data that may or may not be from the database. The way to represent hierarchical structures in Genexus is through the SDT object, along with the possibility of defining collections. Of course, a business component can be thought of structurally as an SDT. That's why, in the output property of the data provider, we can specify both an SDT and a business component. Also, there's a collection property to indicate whether the output will be a collection of that indicated data type or if it'll be a single item. Therefore, a data provider will always return a hierarchy to the caller, be it an SDT, a collection of SDTs, a business component, or a collection of business components. Whoever invokes it, therefore, is responsible for doing what he or she needs to do with that hierarchical information. For example, convert it into another format for representing hierarchical data, such as XML or JSON, which are useful formats for interacting with third parties. In this example, there is a data provider called getCountries, which will return the data type that we've called countries. As you can see, it'll be a collection of simple SDTs, each of which will take the name countries item. In the data provider properties, we'll have the output property with the SDT object named countries, and the collection property set to false because we don't want a collection of countries. If it were set to true, it would be a collection of collections. In this example, the data provider caller is assigning its result to the countries variable of the same data type as the output. This result will be a specific collection in memory with specific values, those calculated within that data provider. Then, the program that's working with that variable can do anything with it. For example, convert its content to JSON format. Here, Genexus offers different conversion methods between SDTs and some of those other formats. If a new format for representing structured information becomes available in the future, the data provider will remain unchanged. Genexus will implement the conversion to that format and will only have to use it. We can convert from SDT to another format and vice versa, from that other format to an SDT. This no longer has to do with the data provider itself, but with the structured data types. The country collection could have been obtained with the procedure instead of a data provider, and the conversion part would be identical. Let's see this example. Let's suppose that, in the context of an application for a travel agency, we need to display on screen a ranking of countries, ordered from highest to lowest by the number of tourist attractions offered by each one. In our reality, we have the country and attraction transactions with the following attributes. A simple way to achieve this is to declare a data provider that returns a collection of countries where, for each one, in addition to its name and identifier, its number of attractions is added, and then process that collection in reverse order by that amount. As we said, the data provider language focuses on the output. The elements are calculated from the point of view of the hierarchy that will be the result. To represent this example, we create the following data structure that will later be returned by the data provider. Next, we must load this SDT object into the data provider's source. By dragging to it the SDT that will be the output of the data provider, the structure to be loaded is displayed. We can clearly see how its language is oriented towards the output statement. Here we see the input of our data provider, that is, where the data is being taken from. There's a specified base transaction, attributes, and an inline formula. Clearly, data is being taken from the database to convert it into the required hierarchical data. The same result would have been obtained if the data had been statically loaded into the source. In other words, if the input was not taken from the database, but manually coded. As we can see, since there is no base transaction or attributes, Genexus will not bring information from the database. It's also possible to have a mixed input. One part is statically coded, and another part is taken from the database. In this example, we see in the data provider source that the output will show 3 items from the statically loaded collection, and then n more items loaded from the database from the country table records. Note that the from clause had to be moved, so that it applies to the final country's item subgroup and not to all of them. As we saw, this static part, manually coded by us, does not take records from the database. We'll now look at the main components of a data provider's source language. We'll have groups, elements, and we can also use variables. The elements are analogous to the members of an STT. If we think of the hierarchy as a tree, groups are its branches, and elements are its leaves. That is, groups are compound elements. They can be made up of other groups and/or elements. Groups can be static or dynamically loaded. These are called repetitive groups. In this example, the first 3 groups are static. They're loaded with fixed data, while the last one is a group that will have an associated base table and will therefore produce n items in the output, 1 for each record of the base table considered. A group with a base table will be equivalent to a for each command. Groups allow specifying a base transaction, although, unlike the for each, here it's specified by preceding the name of the base transaction or level with the word from. Note that in this example, instead of running through the country base table, what we've done is to run through attraction, using the unique clause so that if there are many attractions in a country, only one is taken into account. And for that one, all the other attractions that have the same country are counted. In this way, only the countries with attractions will be listed in the output. Everything we've seen about the for each command is applicable. If static groups were not required, it would be the same to specify the clauses at the country's item subgroup level or at the parent group level, country's item collection. In this case then, declaring the clauses at the parent group level is equivalent to doing so at the child group level. Let's see another example. Suppose that we don't want to store country data in our database, but that we want to consume it from some service that offers it. So, we'll create a country transaction, but dynamic. That is to say, that takes its data from somewhere else that we'll have to specify in the data provider, which will be built automatically for that purpose once we set the data provider property to true. Let's suppose for the time being that the web service is called getCountries, and that by importing it, the country's SDT is created in our KB. In the source, we must first obtain the collection of countries, and then we simply use the input clause in the country group to be able to run through it, positioning ourselves in each item of the collection so as to have a group with that item, assigning the corresponding value to its elements, which will be the attributes of the dynamic transaction. We will now look at a slightly more complex case. We have a data provider that will return as structure an SDT, which has a collection of bills and a quantity element. In our application, we have the invoice transaction, which has two levels, and the following attributes: the standalone flight transaction and the customer transaction. What we want is that from the invoices that have been generated for each customer between two given dates, a payment receipt is generated for the total of all those invoices. Between these two billing dates, it may happen that not all customers have receipts to be generated, as they may not have been billed in that date range. In the structure to be returned, it's necessary to know how many receipts are obtained from the calculation. And for this, we have the bills quantity member. If in the date range 01/01/2020 to 12/01/2020, there are only invoices for the customers John Smith and Ann Brown, and the output will be as represented in the image, an SDT variable with two members, one of collection type and the other of numeric type. The collection will have two items as shown. In other words, the data provider will return a structure with two elements: the collection of receipts on one hand, and the number of items in that collection on the other. If we drag the SDT to the data provider source, we'll see how it's initialized, where the collection property will be left with its default value false. This is what we want, because we're not returning a collection of bills info, but only one element of that type, which will contain, among other things, a collection of bills. We program the parm rule to receive in a parameter the range of billing dates. And then for the bills group, which represents the collection, we specify a base transaction. Why do we place customer name without assigning a value to it? Because its name is the same as the customer name attribute, and the customer table is being navigated. So, it's possible to use this abbreviated notation. It's the equivalent to writing customer name equals customer name, where the one on the left is the SDT member and the one on the right is the customer table attribute. Note that the use of the variables is the same as in the for each command. There is a problem. In this case, a bill item will be returned in the output even for customers who do not have invoices in the range received in a parameter. How can this be avoided? One way is to change the base transaction to invoice and keep the invoice records without repeating the customer ID and with dates in the desired range. Then, in the internal sum, we'll count the totals of all the customers' invoices that are in the same date range. As we've been saying, it's identical to the logic of the for each. Here we can see, once again, the basic components of a data provider's language. Let's see another example. We want to populate with data the table associated with a new transaction named card, using its associated data provider and data from other tables in the database. We have the customer transaction to record the customers of the travel agency, and trip to record each trip or tour offered by the agency in a given city. There is a sublevel with the customers registered for the trip. Suppose that the travel agency decides that all customers who have booked more than 3 trips will receive a special card of full services type, which will allow them to enjoy all services free of charge. And if they have booked less than 3 trips, they'll receive the partial services type card. each card has an auto-numbering identifier, a customer, and a card type, for which an enumerated domain has been defined that supports only the values full or partial. Now, we want the table associated with the card transaction to be initialized with the correct information. So, we turn on the data provider property and leave the value of populate data set to used to. In this way, it'll automatically create the data provider that is displayed, and we'll turn on the business component property to insert the cards that are returned by the data provider when it's automatically executed in the first run. How is the data provider source declared? We'll create a business component card in the collection for each customer. That's why a customer base transaction is specified for the card group. We know, therefore, that it's a group with a base table. We remove the card ID element from the card group since the ID domain of the card ID attribute of the transaction is auto-numbered. Next, note how the value of the card type element is loaded using a conditional inline formula. It'll take the value of the enumerated card type .full as long as the result of running the inline formula count, trip date, is greater than 3. Otherwise, it'll be assigned the value card type .partial. This formula will count the records of the trip customer table, filtering by customer ID. Then, the customer ID element, which will correspond to the business component, is assigned the value of the customer ID attribute of the base table of the customer group. We can use the abbreviated notation and remove the assignment. Here's an example where the data provider returns a collection of business components whose data is obtained from another table. Once again, it's identical to the case of a for each command. To keep exploring this subject, we invite you to visit our wiki.